on there.
Okay, good morning everybody to the third day of the summer school. And now, today we will talk about that data of all the summer school, but we are talking with databases, about databases, because we have access to data, we have a lot of data, and of course we need to organize this data. We need to know how to store, how to process, how to access the data. Of course, the answer is databases. The answer for that is databases. We cannot have the data in files and organization. We don't know why. We need databases, and we the computer scientists work with databases from really long time. But as you know, we now have new needs. We have the famous 4 or 5 V's, the volume, the velocity. We have a lot of data. We have new requirements. So today we will talk about big data databases. Big data databases, another thing that we will have with an expert. The expert we have for this lecture is Dr. Jiaheng, that he's from Singapore, but he was awarded his PhD in the National University of Singapore, but he has experience of all over the world, because he has, after that, he was in California, in the University of California in Irvine in a postdoctoral position. Then he taught also in university in China. And now he is in Helsinki, in the University of Helsinki. And all this experience, he has been working with data management, data databases, and how to organize, and how to process data in such an environment. So I will pass the word to Jiaheng, and thank you very much.
Okay, thank you for the introduction. Hello everyone, good morning. My name is Jiaheng. Now I'm working in University of Helsinki, Finland. Today I will introduce you some technique about the bigger data database. Yes. So this is the schedule today. I will talk about 2 hours from 9 to 11. Firstly, I will introduce you some basic concepts about the big data. I will introduce you 4 V's. Then I will introduce you some technique about the big data. I will first say something about Mapreduce and Hadoop Hdfs. Hdfs means Hadoop file systems. Then I will give you some exercises. You have to answer 10 questions. Then for the second part, I will introduce something about a NoSQL database. NoSQL means that not only SQL means that we want to develop some new database to manage the different type of the data. So we call it NoSQL database. Finally, I will also give you the second exercises about the NoSQL database. Yeah, so this is the schedule today. Then first, let's see what is big data. Maybe you already know something about the big data, but this is difficult for us to give a precise definition about the big data. How big we can call the big data. This is very difficult to define. But we know big data means that the size of the data is so big, so that we cannot use the previous way to process the data. So this kind of data, then we can call it big data. Big data come from different sources. For example, you know some the cell phone data, because we have a lot of people to use cell phone. So there are a lot of come from cell phone and come from social network and from the IoT, Internet of Things, and from some purchase data. So we have a lot of way to get the big size of the data. Then we know that in computer science, when we measure the data size, we use the byte. Each byte includes the 8 bits. Then 1,000 bytes we call the kilobyte, and 1,000 kilobyte we call the megabyte, and 1,000 megabyte we call the gigabyte. Then gigabyte, terabyte, petabyte, exabyte, zettabyte, yottabyte. Yes, so we have different measures to measure the size of the big data. Then how large we can call the big data? Usually we can think that the terabyte or the petabyte size data can be considered as the size of the big data. Yeah, so now we will use some technique to process maybe gigabyte or terabyte or even petabyte data. When we say the big data, we usually refer to the 4V. That means the volume, velocity, variety, and veracity. Volume means that, of course, the size is very big. So we mean that the data size is volume. Yeah, of course, we know the size increased very fast. From 2009 to 2020, the total size of the data increased from their 0.8 databytes to 35.2 databytes. Yeah, so the size increased very fast. The data volume is increasing exponentially. And we have the different source to get the big data. For example, we can get a lot of data from Twitter, Facebook, of course, and Google. And we have also a lot of data from the Internet of Things, including some RDF data and the smart meter data and the camera data, GPS data. Yeah, so we have a lot of size data from the different sources. The second V is variety. Variety means that the type of data are different. For example, we have the different type of data like the relation data. From the web, we got a lot of text data and the XML data and graph data, RDF data from social network. Yeah, so we have the different type of data. So this feature called variety. In order to extract the knowledge, then we have to combine this different type of data together and link them together to get some new knowledge. So this is a challenge about a variety of the big data. This is some example about the customer. Single customer, they have the different source of data. For example, this customer have some banking finance, so they have some data from the banking systems, and they have some about our loading history. They have some social network data, and they have some purchase data, and have some gaming data, social media data. But all of this data come from different sources, and they have the different type of the format for the data. Yeah, so the challenge of variety means that we have to link all the different data together to gain the new knowledge about these customers. So this is a very important application for the finance and the banking. Then the third V is about velocity, means that the speed of data is fast. So data is generated very fast and need to be processed fast. Then we have two examples about velocity of the data. The second one is about e-promotions. Based on your current location, then company maybe know your purchase history, and they have to send the promotion information to you very fast. Yeah, so this is velocity of the data. The second is about healthcare monitoring. Some sensors have to monitoring your activities and bodies. Any abnormal measurements require immediately action. Yeah, so this also gives some challenge about velocity of the big data. Then we already talked the 3 V of the big data: volume, velocity, variety, and finally the V is veracity. Veracity means that data have some doubt, means that the data is uncertainty. Maybe it comes from internet or some social network, so you cannot confirm the truth or not for the data. So this is called veracity. So we have the 4V about the big data. Then about the big data technology, they have the different level to process big data. Firstly, we have some data warehouse and the platform to process the big data. Then we have a different mechanism to the storage of the big data. Then we also have some computing platform to do the processing for the big data. Finally, we have some application level to do the visualization and the data analysis for the big data. Here we have the different technology, but today I will focus on the two representative technology. I will talk about Hadoop Mapreduce technique, and I will also introduce how to store the big data using the Hadoop Hdfs. So today, I will just focus on two techniques about the big data, Hadoop Mapreduce and Hadoop Hdfs. Okay, so we go to the second part about Mapreduce and Hadoop Hdfs. Yeah, so what is Hadoop? Hadoop is a yellow elephant. Actually, this one is the name of a toy. Hadoop, this is Apache top-level project. This is open source, and this is framework for reliable, scalable, and distributed computing and data storage. So Hadoop actually comes from the Google, because Google published 3 papers. So they just do the implementation of this Google technology. So in 2003, Google published a paper about Google file systems. So Hadoop do their implementation for the Hadoop Hdfs. So Hdfs borrow many ideas from the Google file systems. Then in 2004, Google published the second paper about Mapreduce. So Hadoop also do the implementation for the Mapreduce. Then in 2006, Google published the third paper about the big tables. This is kind of database. So Apache also do implementation for the HBase. HBase means Hadoop database. Yeah, so their idea most come from the paper of the Google. Yeah, this is a brief history about the Hadoop. Hadoop is developed in 2005 by the Dot Cutting and Michael. Then they are bought by the Yahoo. Then in 2008, Hadoop win the terabyte sorting benchmark. Terabyte sort benchmark means that they want to sort 1 terabyte data. Then in 2010, Hadoop develops 3 components about HBase, Hive, and Pig. Then in 2013, Hadoop developed Hadoop 2. Then in 2016, Hadoop released Hadoop 3. Now we use Hadoop 3, Alpha 2. So now I introduce some technique about Mapreduce. What is Mapreduce? Mapreduce includes 2 steps, map and reduce, to process the big data. Firstly, let's see an example about Mapreduce. Assume you have a very simple example to do the counting. Consider the problem of counting the numbers of the frequency of each word in a large collection of the documents. That means you have to count the frequency of each word in a large collection of the documents. So in order to process this task, if you have only 1 computer, then this is very easy. You just read each document and use some variable to store the count for each word, then use them together to get the total frequency. So we can finish this task. But how we can do this job in Hadoop? How we can do this in parallel? means that you have multiple machines to do the word count. So how we can do this job? Yeah, so this is the example for the MapReduce. Yeah, how we can do the counting the frequency of each word in a large document, and each machine have only part of the document. Yeah, so we have to sum the frequency of each word together. Yeah, so this is the example for the MapReduce. Then we see some examples for the MapReduce, how MapReduce do this job. Then assume we have 3 different machines. They can do some job of mappers. And each mappers have only part of the documents. In this examples, we have very short document. For example, for this machine, mapper 1, this have 2 documents, Trump and Donald Trump. Maybe this is a very short document. Then for the second machine, we have the 2 documents, Trump, Clinton, and President election. Yeah, so for each machine, we have the 2 documents. So our task is to compute the frequency of each word in 3 machines. For example, in this task, Trump appear twice. Yeah, so we need to sum together to get 2 for these 2 documents. Another example, this Trump appear 1, 2, 3 times, or 4. Yeah, so the Trump appears 4 times in these 3 mappers. Like the Donald appear twice, this one and this one. Yeah, so our task is to count the frequency of each term in these 3 machines. How we can do it? Then first we have used 1 machine to read each document. Yeah, so now we have 3 machines. And we output the frequency for each word in each machine. That means that, for example, in this mappers, we just output the Trump 1. Trump 1. So that means that this word Trump appear only once in this document in this machine. Yeah, so this means that this Trump appear once for this document and this machine, so Trump 1. Similarly, Donald 1 and Trump 1. Yeah, so this is the first step of the mapper. They just output the key value pair. K is the word, value is 1 in this examples. Yeah, so this is first step. We just input the document and output a key value pair. K is the word, value is 1, means that this word appear once in this document. Yeah, so this is key value pair. So in the second step, they just do the transformation. They want to move the data from mapper to reducer. Mapper and reducer may be 2 different machines in the computer clusters. Yeah, so now in the second step, they just move the data from 1 machine to another 1. They just move the key value pair from mapper to reducers. But when we move the data, they want to cluster by the key values. Means that if 2 key value pair have the same key, then they should go to the same machine, same reducers. So this is key point for the MapReduce. In this example, now previously we see these 3 word Trump, they appear in 3 different machines. But now after the move of the data, they will go to the same machine here. Yeah, because later on we have to do a reduce to compute the total frequency. So we have to move the same key to the same place. Yeah, so there's 3 different Trump go to the same machine. Then we have only 1 reducer which contain 3 different key value pair from 3 different machines previously. Yeah, so this is the third step. We just move data from mapper to reducer and group by them based on the value of the key. Yeah, so this is third step. So the next one, we just sort, because when we move them, they are unsorted. So the next one, we just do a local sort. This sort only implemented for each machine locally. Yeah, so we just sort by the alphabet orders. Yeah, so here in this examples, now we have the 4 k-value pair for the trump. Yeah, so then we sort. In the 5th step, we just sum the frequency for each word in the local machine. Yeah, so in this examples, we just sum together 4 trump, then we get the value, the final value for the frequency of the word trump is 4. Yeah, so in this example, we get the final answer for the frequency of each word in the whole cluster. Yeah, so this is 5 steps for the MapReduce for this example of the word count. Okay. Yeah, so this is just the simple examples. Firstly, we get the k-value pair, then we move data from mapper and reduce, then sort by the key. Finally, we compute the total sum of the frequency of each word to get the final results. Okay, yes. Have you other questions? Okay, then we summarize this data flow. Firstly, we have the different data. They are distributed in different mapper. Then in the first step, we just output the k-value pair as the intermediate results. Then we do the shuffle. Shuffle means that we move data from mapper to reduce based on the key. Finally, we do a reduce part to sum together frequency of each word and output the final results. Yeah, so this is the data flow for the MapReduce. And we can see if you use Java, then we can see the pseudocode of the Java. This actually is quite simple. We only do the implementation of the 2 functions in Java. One is mapper, the second is reduce. Mapper means that we just input the document name and document contents. Then we can read this one. For each word W in input value means the document, means that for each word W in your document, we just emit the intermediate k-value pair. W1 means that this word appears once in this document. Yeah, so the function of map is very simple, only 1 sentence. For each word W in document, output W1. Yeah, so you only do implementation for the mapper, like this way. Then the second function is reduce, means that we want to combine the results for the same key and go to the final frequency of each word. In the function of reduce, first we initialize the results is 0. Then for each v in intermediate value means that all the values for this word. Yes, so for this word, for this key. So for each value, in the previous example, each value equals 1. So it means that for each one, we just sum together for all integers and add the final value to the variable of result. Yeah, so that means that we just sum all 1 together to get the final frequency for this word. Then finally, we output the final results. Yeah, so reduce part also very simple. We just sum the frequency for each word together. Okay. This is the Java code, pseudocode for the map and the reduce function. Yeah, so this also shows the data flow of the MapReduce. For the different documents, we have the different machine. Then each machine do a 1 mapper, and we output the different k-value pair. In this example, they output 2 k1, k1, k2, and output different k-value. Then they do a shuffle, means that move data from mapper side to reduce side. Then they do the group by for the key. So this k1, k1, k1 go to the same reducers and output k1 for v. In the step of reduce, they sum all the v together to get 4v, so we output the key for v. So in this way, they finish the task of the map reduce. Okay, please.
The example that you is really good to explain the process, but share with us a real example to see how can be, where is used this kind of technique?
Yeah, we have to do implementation use Java code for the map and the reduce. Yeah.
But an example of a database that you use this technique, that I imagine that you are collecting many data, and at the end you want to analyze it. But a real example of where to do MapReduce process?
In this example of word count, we only do the coding for the map and the reduce function. Yeah, but if you want to do some more complicated job, then you have to do some new things. Yeah, but your only task is to do the implementation based on the map and the reduce function. Yeah, so here.
He's asking for real application
Yeah.
of that, but real application, for instance, Google. The search model Google, they are analyzing millions of documents to what the data and so on, to put it in the ranking Google and so on. Or
Yes.
for instance, when someone is analyzing Twitter
Mm.
to see the tendency, the trending topic in Twitter is a clear example of this one.
Yeah, but they also to develop
Google,
some.
the origin
Yeah.
of the MapReduce and the interface is Google because of the million of documents they are
Yeah.
analyzing.
Yeah, but they need to do the new implementation for the map and the reduce function. Yeah, so this will based on their own applications. Yeah, but for our task of the word count, we only need to write these two simple sentences to finish the previous example. Okay. Good. Yes, so this diagram gives you more detail about how MapReduce run in Hadoop. Firstly, they have some user program. Then they have the master node. When the user program fit this master program, then they can run. The master program work as the coordinate of the whole system. And then data distributed in different machines called workers. So each work contains only part of the big size of the data. Then, for example, the data can be partitioned by the key. And each map workers will read part of the connection of the document to different machine. And then they can do the redistribution of this different key value pair to the different workers. So master can work as a coordinate to assign a different mapper and to assign a different reducer. So master node can control almost everything for the running of one MapReduce job. Yeah, so then the workers also do reduce. Then finally, they will output the results in different machines. Yeah, so then this is about MapReduce data flow. We will see this more in the Hdfs. Hdfs will work to control one processing of the MapReduce job. Okay, we can see more about MapReduce, about Hdfs. Hdfs means Hadoop file systems. So this one is used to manage and to store the big data. So this is called the file system. The basic Hadoop component include 4 different components. The first is the Hadoop Comma, which include different library and utilities. The second is key part about Hdfs is Hadoop distributed file systems. This is the distributed file systems to store the big data. The third one is Hadoop Yarn. Yarn is used to manage the resources and do a scheduling of the different jobs. Then the fourth component is about Hadoop MapReduce. This is the programming model for the large scale of data process. Yeah, so the key component for the Hadoop include the Hadoop Common, Hadoop Distributed File System, Hadoop Yarn, and the Hadoop MapReduce model. Yeah, so this is the main architecture of the Hadoop file systems, which include 3 different components. The first one is the Hdfs client, means that the client wants to fit the data and program to the Hdfs. The second component is name node. Name node, the function of name node is to monitor the processing of the whole systems. All the metadata information and the category are stored in the name node. Then each different chunk of the data is stored in the data node. So in this example, I have 2 name nodes and 5 different data nodes. Yeah, so each data node will store the part of the big data. Yeah, so the HDFS architecture includes 3 parts: HDFS client, name node control everything, and data node to store everything. Yeah, so then when the data is fed to the Hadoop file systems, the name node will assign this data to a different data node because name node have almost everything about the whole clusters. Yeah, so data is written to the local disk, and the name node can contain all the metadata information and the namespace and all informations. Between name node and data node, they can use a heartbeat to do the communication between the name node and the data node. Heartbeat means that in every second, the data node will send some message to the name node, and they have some communication for each status. Yeah, so this is heartbeat communication. Then have some unique feature about HDFS. The first one compared to the previous file systems. The first one is failure tolerant, means that the data is distributed across multiple data nodes to protect against the machine failures. So this is very robust for the systems. It's failure tolerant. The second feature is about scalability. Data transform happen directly with the data node, so the read-write capacity scale fail well with the number of data nodes. So they have very good scalability for the HDFS. And HDFS is designed to process large data sets with write once, read many semantics. So this is not very good fit for the low latency access. Means that if you want to do very frequent update of the data, maybe the HDFS is not a good option because this is very slow to write the data. But it can be efficient for the read large size of data. Yeah, so if you have a lot of IoT Internet of Things process, maybe Hadoop HDFS is not a good option for your task. The HDFS is very good for some of the page rank or maybe like the word count, some Google applications. Yeah, so HDFS data organization. Each file written to HDFS is split into a different data block and stored in the different data nodes. And each block is stored on one or more nodes, and each copy of block is called replica. And usually we have 3 replica for the same data. And some block placement policy, because they have 3 different replica, so the first replica is placed on the local node, means that they will place on one data node. The second replica is placed in the different rank, because in computer cluster we have different rank. So the first replica is put one data node. The second one should be go to a different rank for the safety of the data. Then the third replica is placed in the same rank as the second replica. Yeah, so the third data will be the same rank as the second replica. Yeah, so this is default data placement policy in HDFS. Yeah, now we use Hadoop 2. Previously, they have the Hadoop 1. Hadoop 1 includes 2 parts, the 2 main parts about Mapreduce and Hdfs. But now we use Hadoop 2. Hadoop 2 includes one new component about Jiaheng. Jiaheng is used for cluster resource management. So this is the new things for Hadoop 2. Then I briefly introduce about HDFS in Hadoop 2. In Hadoop 2, they use the Hdfs federations, means that they have multiple name node. So they have multiple name node servers and multiple namespace. Namespace is used to manage the catalog of the whole clusters. And then they can provide high availability, and they can also use for the heterogeneous data storage and archive storage. They can support different RAM disk, SSD, and different ways of the D disk. Yeah, so they can support the heterogeneous data storage. And in order to improve the performance of Hadoop systems, we need to do some tuning. Tuning means that we want to change some parameters of the Hadoop to optimize the performance of the job. Yeah, so I also briefly introduce some technique how to do the performance tuning to improve the performance of the HDFS. Usually, we will modify the different type of parameters for the HDFS tuning. For example, we will modify the block size, we will modify the replicate number, and we will also modify some important parameters in name node and the data node. Most of the parameters will be stored in Hdfs site.xml. If you want to use Hadoop systems, you need to modify this XML configuration file to modify the parameters. Yeah, so firstly, I briefly introduce about block size. Block size is a very important parameter for the HDFS. Block size will have some impact on name node memory, number of the map task, and hence the performance. Default value for the block size is 64 megabytes, but it can be also changed, become larger. Then it can be also use 128 megabytes. This will depend on the total data size and the number of machines in your cluster. If we set the block size is too small, then we have the small block size, then they will increase some overhead for the big file transfer and seek, because data is spread to the more blocks. So if each block size is too small, it will increase the overhead of the data transfer and seek. If our data is small, but we set too big block size, then we will have the too few tasks. This task means the map reduce task. Then we have the too few map reduce task, and then we have the lower parallel of the map task. So this map reduce job will become slower for the small size of the data. So we cannot set the block size too small or too large. They have some trade-off. Then secondly, the second parameter is about replication factor. As said before, the default value for the factor is 3, but we can also modify it to 2 or 4 or even 5. If we set it too small, then this will reduce replication cost and less robust. But if we have too many replications, then this will make the data locals, and this will also include the number of the workers. This also will reduce the efficiency of the map reduce job. Yeah, so we cannot set it's too small or too big. Then we also have a lot of the other parameters for the Hadoop and HDFS systems. For example, we have the DFS data node handle count. This can set the server threads traits on each data flow. This will depend on the CPU job of the MapReduce. So you can decide the number of server threads. This will depend on your CPU speed and CPU configuration. And the second parameter is about the maximum block per files, means that per file you have the maximum number of the blocks. This also can depend on the data distribution and data size. Yeah, so we have a lot of different parameters to tune. Then you can go to this link to find all the parameters. They have about 60 parameters you can change. Yeah, of course, we need some algorithm and some method to do the automatic tuning. Yeah, so we already do some research on this paper, and we also developed some toolkit to do the automatic database, to do the automatic Hdfs and Mapreduce job tuning. And if you are interested in this topic, then yeah, maybe you can read our paper and we can have more discussion about the parameter tuning for the Hadoop and Mapreduce. Okay, yeah, so for the next one, then you can do some exercises, and I prepared 10 questions about the previous topic I have taught. Yeah, so you can see my slides and answer those questions now.